13.8, today we're going to talk about misleading statistics. So misleading statistics might be when you have a huge outlier or your distribution is really skewed. So we'll go into this. Again, don't overcomplicate things as you work through this, guys. It's really a lot of just common sense, okay? All right, so let's unlock the problem. Mr. Owen wants to move to a town where the daily high temperature is in the 70s most days. A real estate agent tells him that the mean daily high temperature in a certain town is 72 degrees. Other statistics about the town are given in the table. Does this location match what Mr. Owen wants? Why or why not? Use the graphic organizer to help. Okay, so he wants the temperature to be in the 70s most days. All right, the mean is 72, but let's look at the other statistics. So the median is 69. That would be the middle value, so that would mean that at least half of the values are higher than 69 and at least half of the values are lower than 69. The maximum high temperature was 95 and the minimum was 62. So what do we need to find here? We need to decide if the daily high temperature in the town is usually in the 70s. We're going to use the statistics from the table. And we're going to work backwards from the statistics to draw conclusions about how your data is distributed, about the distribution of data. Okay? So the minimum high temperature is 62, which means the high temperature is sometimes less than 70 because the minimum is 62, so it's less than 70 sometimes. The maximum high temperature is 95. So that would mean that the high temperature is greater than 80. And the median of the data is 69. So the median, remember, is the middle. So that tells us that at least half of the days must have high temperatures less than or equal to 69. So at least 50% of the data is 69 or less. So does this meet Mr. Owen's request? Is it in the 70s most days? Well, no, because at least 50% of those days are 69 or less. Okay? So, so the location does not match what Mr. Owen wants. The median indicates that most days do not have a high temperature in the 70s. All right, let's try it again. Miss Garcia is buying a new car. She would like to visit a dealership that has a wide variety of cars for sale at many different price ranges. The table gives statistics about one dealership in town. Does the dealership match Miss Garcia's requirements? Explain your reasoning. So what we need to find is if the dealership has prices that come in a wide variety of ranges, meaning the prices are kind of all over the board. What information do you need? Well, we need to use the statistics from the car table, where the lowest price is $12,000, the highest price is $65,000, the lower quartile is $50,000, the median is $55,000, and the upper quartile is $60,000. And how will I use this information? Well, we're going to work backwards to look at how spread out my data is. Okay. So the first thing, boys and girls, you need to do is you need to do a box plot. So remember, a box plot has 5 plots. It has the lowest price of $12,000, so plot at 12. The highest price at $65,000, so plot at 65. Lower quartile is 50, plot at 50. Median is 55, and upper is 60. So you should have plots at all of those, and your box plot should look something like this. Okay? What does this tell me? Let's think. So this tells me these are cut into quarters, right? So 25% of the cars are from 12,000 to 50,000. And then this is 75%. So 75% of the cars are from 50 to 65,000. So your range would be 65,000 minus 12,000, which is 53,000. The interquartile range would only be about 10,000. 50% of my cars are in the interquartile range, right? So interquartile range is really small. So the range is misleading because most of the prices are between 50 and 65,000. 75% of the prices are right here, 50 to 65,000. So the deal does not meet Ms. Garcia's requirements because there's not a huge variety of prices. And then the next question, what would the box plot look like for a dealership that does not, or that does meet Ms. Garcia's requirements? So if Ms. Garcia, can you still see it?
Mm-hmm.
Okay. If Ms. Garcia, in order to have her requirements met, your lower quartile would be somewhere down here, okay? Because that would mean both your range and your interquartile range are big. So in order for the box plot to meet her requirements, the lower quartile would need to be much lower to make the interquartile range larger. When the interquartile range is larger, most of the data is very spread out. Okay, let's look at share and show. Okay, Josh is playing a game at the carnival. If his arrow lands on a section marked 25 or higher, he gets a prize. Josh will only play if most of the players win a prize. The carnival worker says that the average mean, because mean is just another word for average, that the average score is 28. The box plot shows other statistics about the game. Should Josh play the game? Explain your reasoning. So remember, he only wants to play if most of the players win a prize. And to get a prize, they need to get 25 or higher. Okay, let's look at the median. Our median is 20. Okay, if your median is 20, what does that tell you? Well, it tells you that at least half of the players scored 20 points or less. At least half. So the median is the middle value of the data, so at least half of the values are equal or less than 20. So if at least half of the values are 20 or less, do most people win a prize? Do most people score 25? And the answer is no, because half of the players scored a 20 or less. Most players did not win a prize, so Josh should definitely not play. Keep his money. Okay, what if a score of 15 or greater resulted in a prize? How would that affect his decision? So 15 or greater. So if the prize line was right here, should he play? Absolutely he should play, because this is most of your data, 75%, because if you see this is 25%, 25%, 25%, and 25%. So 75% of the people who play get a 15 or greater. So Josh should play. So the lower quartile is 15. So that means most of the data values are 15 or more. And it would definitely meet Josh's requirements. So if 15 was the prize line, he should play. Okay, last one on share and show, then I'm gonna set you free to do your own. A store collects data on the sales of DVD players each week for 3 months. The manager determines that the data has a range of 62 players because he took the maximum minus the minimum, 78 minus 16. So the manager determines that the data has a range of 62 players and decides that the weekly sales were inconsistent. Use the statistics in the table to decide if the manager is correct. So we already know that our range is 62, but let's find our interquartile range. So subtract the upper from the lower, and you get 14. So if your interquartile range is small, it does not vary often. So were the sales inconsistent? No. Although the range is 62, the interquartile range is only 14. And since the interquartile range is very small, the data does not really vary that much. All right, guys, so you have on your own and homework. If you have questions, log into Teams and we'll help out.